Oh, you know what, I bet it does that for security, like, so that somebody can't like remotely record your screen and you typing in passwords and stuff.
This one sounds far worse than it is. Don't let the word transcendental make it feel like these are difficult. Transcendental, for the most part, will just be exponential. But it also includes some various trig ones. So I figure I'll try to cover as much as we can. Now, to me, the exponential ones are covered way more than they need to be in this packet, or way more than I hope they need to be, I should say. Do you guys remember the difference between growth and decay? Because I think you did a lot of that in pre-calc, right? Like for radioactive dating and stuff. Okay. Growth is when something has a base bigger than 1. So like 1.5, so it grows. The one below it technically is growth. The negative in the very front just means it's upside down. We don't have to debate whether that's growth or not, they just consider it growth. So E is a number like pi. I should know what it is, and I always forget that it's 2.4 or 2.7. Yeah, I know it's on the calculator. I feel like it's 2.4. 2.7. I figured. 2.7. Okay. We use E a lot this year, but we never use the decimal equivalent of it. We only use the E button. And we mainly use it for natural logs, not by itself. So that one's technically growth because the 2.7 is bigger than 1. The bottom one is the one that most people may get thrown off on. I feel like you've answered a couple times this week already, right? Do you want to just call on somebody else so they can answer? Raise your hand. Why is that growth if it's 2/3 and it's smaller than 1? And if you
plus 1.
Oh, I'll take a break and go get a drink. I need some more caffeine. You've got a lot of people to confer with.
What should say?
I didn't hear her.
The exponent is negative.
What does that mean? Oh, go back to it.
Yeah.
What she said, is that what you're going with?
Yeah.
Come on. A negative exponent technically means you divide that many times in a row instead of multiplying by that many times in a row. Virtually everybody, instead of using the negative exponent, will write it as 1 over that thing. So a fraction flips upside down instead, because 1 over 2/3 is 3/2. So 2/3 to a negative power will be 3/2. I'll write that if that helps. 2/3 to a negative power is equivalent to 3/2 to a positive power. So you're going to have to be on the lookout for that. So that's why all 3 of these columns are considered growth. And you're going to see duplicate, but the exact opposite in the other category. All of the decays are a number, this is where it's super annoying, but I think it's sort of obvious, but it has to be a number between 0 and 1. Can't be a negative number. A half, between 0 and 1, answers get smaller. A half, between 0 and 1, answers get smaller. The negative in the front just flips it upside down, has nothing to do with considered growth or decay. Demetrius, should we make you answer this one or not? So what would this be equivalent to?
1/2.
Excellent. That was a good catch. Okay. This is equivalent to 1 over 2 to the positive x minus 2. Demetrius, do you want to call somebody else for me?
Yeah, Skogs.
Skogs? I kind of like that. Wish I would have known that a long time ago. I would have never even had to learn your siblings' names. What does the minus 2 do?
The -2 means that on the y-axis it goes down 2.
Perfect. You move the entire graph down 2. So transformations, if you remember those, the plus and minus at the very end move the entire thing up or down. Okay, growth, get bigger. Decay, get smaller. We don't care if it's upside down or not, we ignore that part. I do not. If you go to page 2, I virtually want you to ignore this entire page. Now, everybody has different methods of things. So unit circle. For many years, all the pre-calc teachers had everybody just memorize the unit circle, and that's all they went with. And which is fine, while you're using it. And as soon as you stopped using it towards trimester 3, every single person when they got to calc had zero knowledge of the unit circle. Because they just, once they stop thinking about it, your brain forgets. This, in my opinion, is the exact same thing as just trying to memorize everything. Calc has way too much info by the end of the year to try to just memorize everything. It is far better for you to learn how something works so that you can just do it every time and not have to memorize minute details of everything. Case 1, case 2, case 3, that sounds terrible to me. Now, growth and decay, I think you guys are fine with. Like, that's something you've done multiple times. This, worst thing I've ever seen in my life. Not one of you is going to have all of this memorized for the test. And I wouldn't want you to, because then you would forget other things from this unit that are just as important, if not more important. So, I don't like this, because I want you to just learn how something works and go with it and figure it out every time in your head. Memorizing cases, to me, is the worst plan for an AP test you can think of. Now, having said that, that table talked about increasing, decreasing, which we do a lot of this year. Wait, who did you, oh, wait. Who are we gonna go with?
You can 5.
5. What's increasing? Oh, I don't know, we got a lot of Y's. If you had to say increasing to somebody in pre-calc knows 2 right now, how would you explain it to them? Don't look at this picture, nothing up here.
Increasing is.
Oh, you're way overthinking it. You absolutely know what increasing means. Your grade increases. It goes what? Yeah, that's all it's looking for. Yeah. I could tell you're trying to search for some sort of math term type thing. I want you guys to remember increasing means going up. Decreasing means down. Good. So if I were to get this, what I would look at, because you're not going to have a picture, I would see 3 halves, and I know the thing's getting bigger. Shouldn't say that. Growth. I know it's growth. I know it's down 3. Well, then what I would do is I would make a quick sketch of something. Down 3. I don't even need the label, it's down 3, right? Growth. I don't care where it crosses. I could figure that out if I wanted to. I know that's what growth looks like. If it had a negative in front, I could flip it upside down, like that. Is this increasing?
Yes.
Okay, how do we know? Why not? Good. Make quick sketches for lots of things that don't have details. They're there to like help your mind work a problem. That is literally how I do everything on the unit circle, and I have never memorized anything because I've never needed to. And I'm just gonna, there is so many facts by the end of the year that you have to memorize. You need to learn things that help you do something rather than memorize it. We haven't even gotten to derivatives. There is, I believe, 35 derivatives you have to know. and there is, I don't know, 45 integrals you'll have to know. Those are just formulas. So you don't want to memorize everything, you don't have to. You want to try to focus on what's important and work with it. Okay, I know we have the picture here, we're just going to go with it. E, I know that is growth. Up to, upside down. And it doesn't matter what order you do that, to be honest. You can do it whatever order you want, it still works. So up to. Growth, well, I would draw like that, but I know it's upside down, so I flip that upside down. And again, I don't care where it crosses, I could figure that out if I had to. Is that going up? No, it's going down. I want to do this one, because that's the one that throws everybody off. It's already drawn, I don't need to redraw it with you, I don't think. This one is decay coming downwards, flipped upside down, up to. Is that growth or decay? Is that going up or going down? Going up. This is going to be considered increasing. Do not tie increasing and decreasing with growth and decay. That's actually what the point of that table on the next page is. They're not tied to each other. They are found separately. They say separate things. So don't equate one to the other. I don't know, is that part okay? Okay, this was supposed to be the first 45 minutes of our lesson, but I felt like it didn't need that long. I mean, I don't care if you remember how to graph those, you can always make a table if you need to later. I want you to remember the important parts of the things. Oh dear. Okay, now we're going to go back to our, what I call discrete math, which just means like wonky numbers. Doesn't work right. It's not real things. I'm going to plug negative infinity in for x. Negative. Is that growth or decay? Decay. So that means it's getting smaller, okay? I'm not going to write decay, but you can if you want. So, every single one of these we're going to be able to just plug infinity in. None of these will go by like an answer that doesn't work. Because on exponentials, both sides automatically have an answer. So none of them will never not work. Somebody help me out here. I don't know. We have to figure this out in our mind using reasoning. That's what we're supposed to be good at if we're in calc, is how to reason through things. If I have a decay number and I do it 1 trillion times, I don't know, is it going to get bigger or smaller? Smaller. What does the negative in the power do though? Flips it. Oh Lord, now we've got 1 over 0.3 to 1 trillion times. Is that going to be a small number or a big number? Big. Okay. I am going to replace this with a big number. Negative in front makes it a super big negative number. I don't care, you use billion, whatever in your head, right? Like whatever helps it make sense. You got a really big negative number, plus 2. What's the plus 2 going to do? Nothing at all. Like, that's worthless. It's not going to change your answer. So, the limit as x approaches negative infinity will be negative infinity, a big negative number. You're trying to figure these out using reasoning. Infinity isn't a real number, so you just kind of have to like work with it for what it is. And that way, this way is why I don't want you to memorize cases. That's how the cases work. Because it is so confusing. trying to remember if you have decay to a positive or negative power and or a negative in the front. Because I have seen students try that method and it just gets so confusing to them with the negatives. Okay. See if you can figure that one out on your own. Neat. Yeah, see if you can figure it out on your own, then we'll go through it together for sure. When we get done? 06, my bad. Okay. I'm trying to hurry. FYI, we're definitely gonna go over 1.5 again Monday. I just wanted to try to get through it as much as I could so you can work on it. But we'll definitely go over it more and answer questions. Okay. So, negative of negative infinity would be positive infinity. Plus 1, useless. Plus 1's not going to do anything to infinity. This answer will be big or small? Big. That's all you're trying to figure out, FYI. Whenever you're working with infinity, the answer is generally going to be infinity or 0. That's why I'm trying to say big and small in my head. Minus 3. Nothing. That doesn't do anything at all. Now, if you doubt yourself, and you're not sure if you did it right, how can you find out? Oh, that's true. Didn't even think of that. Where would you say that? Neil, is that you? Yeah, that would work too. I was just going to say graph it, and then look at the graph. On the left-hand side of this graph, it should go up, according if we did it correct. Should we pick another random one to see if everything's going okay? Because they're all done the same way. But I want one that's going to have a horizontal asymptote. So
You need what was just infinity.
that's true. It's a good point. Every one of these, one side is going to be infinity or negative infinity, the other side is going to be a number. Sure, let's do that. We know that'll work. Let's do B with positive infinity. I don't care where you write it. This is kind of how I go through it. I literally just write infinity in and figure it out from there. Okay, e to the negative infinity plus 1. The plus 1 is worthless, doesn't change a giant number. The negative infinity means 1 over e to the infinity. E to the infinity is going to be a crazy big number. 1 divided by a stupidly big number is equivalent to nothing. The top is so much smaller than the bottom, it's worth nothing. Like, if you in your calculator, if you did 1 divided by a billion, it's a small answer. So this is effectively replaced with 0. Because that's what happens with infinity. And then 0 minus 3 means the horizontal asymptote would be at negative 3. That's how this entire page will work. The 1/2, I don't know if that would confuse you, like, it's similar to when we did 0.3 on the first one, right? Like, you try to figure out if the answer would get bigger or smaller type thing. Okay, I want to go to the last topic, which should be, and not this. There we go. It was trying to make a point that with trig functions, well, there could be holes in the graph too. You just may not even know it because it doesn't always look like it when you look at the equation. We don't need to know that point. These are what I want to get to because these you will see far more often than anything else. The AP test every year has at least 2 of these questions. And they are extremely simple and quick to answer if you spot them. This says the limit as the angle turns into nothing, sine of the angle over the same angle info, The answer should be 1. Now this gets proven with the squeeze theorem / the table, however you want to do it. The answer is 1. What I want you to understand, whatever that angle is, it doesn't matter what that information is. It could be written as 500,000 x. You don't care what it is. All you care is the bottom has the same info. But the bottom isn't an angle. The bottom's just written as its own. So it doesn't matter what that angle is, as long as the bottom matches it. Because that's what you're going to run into on the other problem. Okay, the answer will be 1. The second one, I mean, obviously you can read it, but I don't even remember who answered that. No, did you call somebody? No? Who answered last? Doesn't matter, I'll just pick something. Seth. You were trying to avoid eye contact, that's a giveaway right there. I'm cruel, I'm gonna zero in on it. Some people get confused between sine and cosine because you see them so often they look the same. That doesn't matter. How would you immediately know the difference between these two in an equation? What would be a giant difference that you could spot?
One for the sine, one for the cosine, and then the numerator, one has a 1 minus.
Okay, perfect. The sine and cosine part I'll ignore, because what you're gonna find is that in trig, sometimes it's not written as sine and cosine, it could be written as tangent, whatever. The second one has the addition and subtraction as part of it, well, subtraction, but like, if you're going to use this first formula, there will not be any kind of addition, subtraction in the problem. It doesn't work, it wouldn't match up. Second one does. That's gonna be the main difference that you look for. Because they're gonna be hidden in disguise. I'll just tell you that right now. Okay. Let's see, do we have time to actually do a table? Sure. Do those 2 tables. I bet you guys are much quicker at it now that you know your different methods. Make sure your calculator is in radian mode, otherwise your graph won't be correct. Because you guys either chose a table or a graph, but radian mode needs to be for both. Let's, Seth, is there anybody you want to call on? Who'd you call on?
Me,
Oh, you sound happy.
not.
Okay. When you get done with A, can you come up here and write the answers in? Is there somebody you want to call on for B?
6.
It's not even 6 people at that day. No, you're right. 6. Sophia, you got B. You want to start out and fill out info for B? Can you do B? When you get done with it, come up and put the answers in? So you can do that one first if you want. You got this. I can help you check, I can help check it over or whatever if you want to. Same thing, Donald, if you want me to help you with it or check it over again.
How do you put the calculator in radians?
Oh, that's a good question. How do you not know that one by now?
I just got this kind of line.
Oh, really?
Yeah,
What'd you use last year?
just like a normal one.
Really? Oh, that's impressive.
Not a great
Okay,
calculator.
mode. So on the top of the calculator, mode is how you change it between everything. You actually use that button quite a bit, so.
Sounds good.
Do you have physics?
I do not.
Okay, then it won't matter. Then your calculator will be in radians all year, so you won't use that button at all. People who have physics have to do it like every day. In fact, let me go put the answer up here for you.
Once we're done with the table, I will show you how to manipulate it from the equation so you don't need to do a table. Because tables are the worst thing ever, they take forever. And if you're not getting the answers to come up on the table, I can kind of show you where it's going wrong if you want. You're not? Oh, okay, bring it up here. What'd you get? Error. Oh, error.
I don't think I put it.
That's pretty much exactly what I was going to say, because if they all came up error, something's off. It was cosine of 3 theta, but that shouldn't matter.
Yeah.
Oh, you put in a theta. Yeah, it has to be in x's, just because the calculator, it has theta, but only if your calculator's in polar mode, so.
So you don't put the 0 and you put
You,
X.
you don't put theta, you put x. You're right, I didn't think of that.
Okay.
I didn't even think of that. I don't know if anybody else was doing the same thing. To be honest, I bet a handful of you were. When theta is the variable being used up there, your calculator gets very screwed up if you try to use theta. Because your calculator only uses theta when it's in polar mode, which I think you might have done that in pre-calc, but like, you don't need it at all this year. So you would put an x instead of a theta, and then your calculator will be happy. I don't know, it's just the way it is. Did you get it to work out? Oh, put them up there. You don't need to, I mean, I can go look at it if you want, but you could just put them up whenever.
That's right, right? Or something close.
Well, that definitely looks like 2.
Okay.
Why were you doubting that one?
I don't know.
And then, Sophia, you can just put those numbers from the table straight up there, because those were correct too. Now, the sine one to me kind of makes sense, that it's going up and then coming back down, because that's often what sine and cosine look like. Now, the cosine 3 theta minus 1, I'm not really sure if that's going to go up and then back down, or if it's going to go up and up again. My guess is cosine would go up and then keep going up, but we'll see. Oh, it's definitely going down, huh? Okay. Oh, thank you. Yeah. Oh, yeah, let me draw you on the chart. There. This is just easier to see from there and everything. Yeah, that's partially what I figured. Okay, did everybody get that? Or somebody have something different? I don't know. Those looked right to me, but I didn't type them in myself. I just knew what the final answer was. Is that what you guys got? Okay. So I'm assuming you guys would have been able to calculate. Well, this clearly is going to 2 because you're adding a 9 each time, so 2 is for sure. Bottom one, 0.4. And this probably was 0.044, and if we would have gotten closer, it would have been 0.0044. You'll notice that they always seem to follow patterns. But either way, it's going downwards. And then on the other side, it was negative, coming towards 0, so both sides are pointed at 0. Okay. Let's see if somebody, does somebody know the answer to C without typing anything in? Perfect. Okay, now that you figured out that answer, how did you get that?
Because it's 1, so now you just use it as.
Oh, that's too much answer right there. You probably made it correct, but that's too much answer. We have people in here who will follow that. I'm just kidding, you guys definitely can all follow that. The numbers that are there are the answer. That's all I was looking. I guarantee you know what it was. The numbers that are there are going to be the answer. It's super easy. And these are awesome questions on the AP test. Because you don't have to show work on multiple choice, you just answer it. So if you get this question on the AP test,
That's your answer. And that is how I knew the answer for the first one. It was 2/1. Because remember I made an emphasis up top that whatever was there for the angle, the bottom had to be the same thing. So the way we manipulate this and cheat, this only works if the bottom has the same info as the top. So my cheating method would be to multiply the bottom by 2, which you guys should know by now, you can't just randomly multiply a bottom of a fraction by a number. So what else would I have had to do? Multiply top. Okay? Now, I cannot touch the angle. I should have said that first. I always have to match the angle because the angle cannot be changed. I can change the bottom by manipulating it, but I can't change the angle. I'd have to use like double angle identity. That's out. One of our limit properties is we can choose when to multiply the multiplier. So I am going to choose to do the 2 on the top afterwards. And so this would say sine of 2 theta over 2 theta. And as long as the top info is the same as the bottom info, this will turn into 1. So whatever the multiplier on the outside is, will be multiplied times 1, and that would be the answer. So this is the actual mathematical manipulation that you do to get the answer. In effect, you just need to know the numbers that are there to get the final answer. Because this 3/4. Shoot. The 3/4, I would pull the 4 out front. And then this would say limit sine 3 theta, because I can't change the angle, over theta, and then do the same trick up there, where I put a 4 in here, not a 4, I'm talking and writing at the same time. I would put a 3 in there, and a 3 up top. The 3 up top I would choose to do out front. So whatever numbers are there just ends up being your answer because of the way it works. Okay, how... Technically, it's the same for b, but it doesn't matter what the multiplier is because b, what is this limit equal to? 0, so whatever times 0 is 0. So this one, if you can manipulate it to look like that one, it'll always be 0, because it doesn't matter what the multiplier is. What I would have to do to this one is factor out a -1 and multiply by 3/3. So I would have -3 times the limit of 1 minus cosine 3 theta over 3 theta. This is 0, and I don't care what's in front, the answer is 0. So this one's generally easier in effect because if you can figure, if you spot it, it's 0. Okay, I'm impressed I fit that all in. I hope it wasn't so fast that you didn't catch much. I tried to highlight the major points. Go ahead.
So on the test, like,
Oh, you have to show it.
so I would have to like show them that?
Oh, yeah, you're right. I should say that for sure, huh? You need to know how to do this manipulation. Because on our test, you have to show me you can figure that out. After our test is done, you can use the quick way anytime you want. That's a very good question. It probably would have been a big deal ahead of time, yeah. Okay, but you got all tomorrow to work on 1.5. I don't even know if you'll finish it tomorrow during class. You might. I will gladly go over and help you with anything on Monday from 1.5. I'll just kind of plan 1.5 for Monday, and won't move on until we're good with 1.5.